Hi guys, and welcome to the first of the videos, the feedback videos on the Combined Science Higher Tier Physics paper that you sat for your PPE1. Now I'm sure you've been told this before, but the idea of this video is for you to actually listen to the commentary and compare how to answer the questions with your own answers, and that way you can identify through the feedback as to why you only scored some of the marks or why you didn't score any of the marks at all for each particular question. Now, what I'm doing is I'm going to do one video on each question. So I'm going to do one video for question one video for question two, etc., etc., for use to gather feedback so you can identify. You don't have to scroll through a whole video, you can just go straight to the video for the question that you require feedback on. And in this particular video, this is video one on question one. So let's start. Okay, so the first question states or asks, which colour of visible light has the longest wavelength? Okay, so in order to answer this question, we've been given some options here. Now, to answer this question, I want to refer you to the diagram of the EM spectrum, which I've got on your screen now. So we know the EM spectrum is a list of waves in order of increasing frequency. So radio waves have the lowest frequency up to the gamma rays, which has the highest frequency. Now, we have to understand why the radio waves have a low frequency, and as we go up the list, the frequency increases to gamma rays, which is the highest frequency. Why is that? Well, we know the definition of the term frequency is the number of waves passing a point per second. What you should know is that the reason why radio waves have a low frequency is because they've got a very long wavelength. Okay, so we know radio waves have the longest wavelength, and that's because that means, as a product of that, they have a very low frequency. Well, if the wavelength is very long, it's going to take a longer amount of time for one wavelength to pass a point, because the wavelength is really long, so it takes a longer amount of time for that wavelength to pass the point, and that will therefore reduce the number of wavelengths passing that point per second. And therefore, because radio waves have a longer wavelength, they've got a lower frequency. Gamma rays, on the other hand, at the top end of the spectrum, have a very high frequency, and that's because they've got a very short wavelength. If they've got a short wavelength, it's not going to take a large amount of time, for one wave to pass a point, because the wavelength is very short. That means you can get more wavelength passing that point per second, and therefore, because gamma rays have got a very short wavelength, they've got a very high frequency. So if we refer to our question, which particular colour of the visible light has the longest wavelength, or we can see the red end of the spectrum of colours that make up visible light is closer to the radio waves, indicating that they have a longer wavelength, or the longest wavelength, up to the violet end of the spectrum of colours that make up visible light, which are closer to the gamma rays, and therefore indicating has a shorter wavelength. So the colours which have the longest wavelength is the colour closest to the radio wave, which you can see in the spectrum is the red part of the visible light spectrum. So the answer to question 1C can only be red, because that has the longest wavelength. Okay, so for question 1B, some television remote controls use infrared radiation, and other remote controls use radio waves. Now, you have to explain why infrared remote controls may not switch on the television from behind an armchair, but a radio wave remote control will. So I want to refer you to information or an area of the EM spectrum that we know. We know some of the common properties of all waves that they share on the EM spectrum that they share is that they can be, they're all transverse waves, they all travel at the speed of light through a vacuum, and one of them is that they are all emitted from a source and absorbed by an absorber. And it's that area that the question is testing you on. So because the question says to you to explain, an explanation question usually is a what and a why question. You have to say what it actually is and why that is the case, or why it is the way that it is. If the question was describe, it's just a what. You just have to say what it is. Okay, but in this case, we've got an explanation question, and you have to say a what and a why. In this case, we don't need the what. Okay, we don't need to what the what with the what because they've given that to you. We know the what is that the infrared remote controls will not switch on the television, but radio waves remote controls will switch on the television. So that's what we are explaining why. Okay, so we're getting straight on for our 2 marks why that is the case. So in relation to what we've just talked about, that all waves on the EM spectrum are emitted from a source and absorbed by an absorber, the answer to this question would be that if you're sitting behind an armchair and trying to turn on the television, which is quite weird, but I mean that's the nature of the question. If you're sitting behind an armchair and you're trying to turn on the television using an infrared remote control, it must be which will not switch on the television from behind the armchair. It must be because the infrared rays given off or emitted from that is absorbed by the armchair. Okay, so they are absorbed by the armchair and they don't reach the television, which is why they do not turn the television on. Okay, that's for your first mark. Another way you could have got the first mark for that is to say, well, why do radio waves actually turn the television on if you're standing behind an armchair? So another way you could achieve your first mark for that particular question is you could say, well, why does a remote control that uses radio waves, why does that turn the television on? Well, that would be because the armchair doesn't absorb radio waves. Okay, so your first mark is coming from saying either infrared rays from the remote control are absorbed by the armchair, or you could say for your first mark that the radio waves from the remote control are transmitted or go straight through the armchair and do reach the television, which is why they will turn it on. Okay, well, why are the infrared rays absorbed and the radio waves not absorbed? For your second mark, you would have to say that it's because they've got different frequencies and wavelengths. Now, we know that the individual properties of the waves that make up the EM spectrum are because they've got differences in their frequency and wavelength. So gamma radiation can destroy cells and are very dangerous because they've got a high frequency, whereas radio waves, okay, have a very low frequency and don't destroy cells because of a difference in their frequency. Well, this question is no different for that second mark. You have to say that the reason why infrared rays are absorbed by the armchair, but radio waves are not absorbed, they are transmitted and go straight through the armchair, is because they have a different frequency, or you could say for your second mark, they have a different wavelength. And that would have been enough to secure you that second mark. Okay, so at this stage, guys, if you need to take any notes or annotate your answers to correct them using the feedback you were given, you can pause the video at this stage and write your correct answers down. Okay, so if we go on to the second question, which is question 1C. Okay, so in this question, we've got a cork floating on water, and you have to use the scale on the diagram to measure the wavelength of the wave. Now, in order to do this, you need to think about two things. First of all, what is a wavelength? What do we mean? What's the definition of a wavelength? Well, the definition of a wavelength is from one starting point on the wave to the same starting point on the next wave. So if we take that definition, which is from one starting point on one wave to the same starting point on the next wave, which is the definition of wavelength, I'm going to show you what I mean by using the cursor. So if we take this point here at 0 as the starting point, you can see the wave is moving upwards at this stage. So where the wave moves up at this stage and then moves down, so where we get to the point on the next wave where it moves up at that point again, that's one wavelength, and that's where it starts to move up again and crosses that 0 line like it did at this initial start point. Well, this point is the same start point on the next wave, and the distance between those 2 points is the wavelength. Now, that's the first thing that you needed to think about when you're considering the answer to this question. The second thing you need to consider is the using the scale. Now the question says you must use the scale, and that's exactly what you need to do if you're going to score the marks, the 2 marks for this question. Now, to work out the scale, what we need to think about is how much distance each little line represents in between the larger spaces. Now, the larger spaces have a distance of 5 centimeters. Okay, 5 centimeters, 0 to 5 is 5, 5 to 10 is 5, 10 to 15 is worth 5 centimeters, 15 to 20 is worth 5 centimeters, so on and so forth. So we know the distance between the large squares are actually worth 5 centimeters. Now we know that we've got 5 little squares in between one big square. So we know that each big square is divided into 5 little squares. And it's how much distance each little square represents that we need to work out. Well, if the distance between here to here is worth 5 centimeters and we've got 5 little squares, then we're just going to do how much is one little square worth, which would be 5 divided by 5. So a distance of 5 centimeters divided by 5 will tell you how much each little square is worth, and that gives you each little square being worth a distance of 1 centimeter. So now that we know our scale and we used our definition of the wavelength, we can see that the total wavelength, which if we took picking it from here to here, the same start point on the next wave, which is here, we can see that that is at a distance of 12 centimeters. So we've got 10 here, 11, and the line of the graph, the curve, or the line of the wave crosses that line at a distance of 12 centimeters from the first start point on the previous wave, and therefore the wavelength is 12 centimeters. Now you don't need to write your units because you've been given the units already, so you just need to write 12, and that will secure you the 2 marks. At this stage, guys, you can pause the video and use the feedback from question 1C to help you to write it down and annotate it on your own exam paper. Okay, so for question 1CII, you have to describe the motion of the cork. Now, the question here gives you a massive hint as to what it wants you to say to secure the marks for that particular question. So you should include how the cork moves relative to the direction of travel of the wave itself. And that is actually quite important information because it gives you a very big hint as to how they want you to answer the question. Another area that we need to talk about to review and revise so you know how you're attaining your marks for this question is the differences between the 2 main types of waves that we learned when we were teaching you waves and the EM spectrum. Now we know that there are 2 types of waves, longitudinal and transverse. And the difference between those 2 waves is what this question is actually referring to. So longitudinal waves, an example of that is sound waves. Longitudinal waves are waves in which the oscillation or vibration of the particles of the substance through which the wave is travelling, so waves travel through substances, in this case they're travelling through water. Sound waves travel in air, so that's the substance they travel in is air. So the particles that make up air vibrate as the wave travels through the air itself. Now it's the direction that the particles vibrate in or oscillate in is parallel relative to the direction of the travel of the wave itself. Whereas transverse waves, such as ripples on water, which this question is in reference to, we know that the particles of water bob up and down or vibrate or oscillate up and down relative to the direction of the wave travel. So for your first mark, to secure your first mark for this question, you had to say that the cork moves up and down. Now to secure your second mark, we have to state that relative to the direction of the wave. So what is, when they say relative to the direction of the wave, they mean, well, what's the difference between the direction the wave travels in and the direction the particles are oscillating in? Well, the particles are oscillating at a right angle or perpendicular to the direction the wave travels in, which is actually the definition of a transverse wave. That's what the question was testing you on. So your first mark for question 1C2 is to say that the cork moves up and down. And your second mark is to state how that is, compare that direction that the cork moves in to the direction the wave travels in. Well, the cork moves up and down perpendicular or at a right angle to the direction the wave travels in for your second mark. And that is how you would have secured your answers for question 1C2. Okay, so for question D, a different water wave has a wavelength of 0.25 meters and a frequency of 1.5 hertz. Calculate the speed of the wave. Okay, so we know from what you've learned and what you've revised in your revision guides and from your classroom teacher that there are two equations you can use to calculate the speed of a wave. The first one is speed equals distance over time. So if you know the distance the wave travelled and how long it took to travel that distance, you can work out the speed of the wave by just dividing the total distance travelled by the total time taken to travel that distance, using the equation speed equals distance divided by time. But in this particular question, we've been given the wavelength and the frequency. So they must want us to use the second equation to calculate the speed of the wave. Now that second equation is wave speed equals frequency in hertz multiplied by the wavelength in meters. What I'd like to point out to you is that there are no conversions required for this question because wavelength is always measured in meters. Wavelength, to calculate the speed of the wave, you have to multiply the frequency times the wavelength. The frequency has to be in hertz and the wavelength has to be in meters. And that's exactly the unit of the values they've given you in this question. So to calculate the speed of the wave from this, it was just a straightforward multiplication of 1.5 times 0.25. That would have given you an answer of 0.375 meters per second. So to plug those into your calculator and to write down the answer on the screen from your calculator would have secured you the 2 marks for this question. Where you're getting your marks from? Well, you're getting your first mark from remembering the equation, recalling the equation, and you're getting your first mark is from recalling the equation, remembering what the equation is, and substituting the numbers values from the question directly into the equation. So you get 1 mark for recall and 1 mark for recall and substitution of the values into the correct equation, and then you get your second mark from evaluation, from the correct answer to the calculation of 0.25 times 1.5. Now they've given you the answer in 0.38 meters per second, but they've rounded it up. If you just wrote it as it is on the calculator screen, which is 0.375, they would have given you both the marks for that. You would have only been given 1 mark if you had written 37.5, 37.5 or 37 or 38 would have only scored you 1 mark. Okay, and that's because somebody, if you had got that answer, it's because you've converted the units when you didn't have to, which is why they're giving you 1 mark because they have to give you some credit for remembering the equation and substituting the numbers in, or even though you've converted the units, you've still remembered the equation and you've still substituted the numbers correctly into that remembered equation, which is why you have only scored 1 mark. But if you hadn't converted anything and got your answer at 0.375 or 0.37 or 0.38, they would have given you the full 2 marks. Okay, so that video concludes the actual video, the feedback video for question 1 of the higher tier combined physics PPE1 paper. All right, so if you need help on any of the other questions, please refer to the video that corresponds with that particular question and listen to the feedback there. All right, thank you.